Hey, what is up, Algebra 2 students? This is Mr. Shack, and this is your Unit 2 review video. Not to be confused with Module 2. This is Unit 2, so it has Module 3, 4, and 5. So 3 through 5 is what's in Unit 2 there. Please make sure you have your volume up. I'm going to write it here just in case you are just watching in silence, just trying to look at the answers. Okay, this is where you can get your explanation of how to do these types of problems. So I highly recommend to have that volume up. If you're just watching to see the answers, you're really not doing it right. You should be watching to make sure your thought process is good, and if you didn't get the correct answer, then watching that whole explanation of how to do that type of problem. With that being said, I only have a limited time, so obviously I do go through these pretty fast. But that's what that pause button, that rewind button, there might even be like a slow down button, like a 0.8 speed or something like that. I'm honestly not positive on that. But you definitely have that pause button, rewind button in order to be able to really take the time to understand each of these problems, because this is what you have to understand for your test to be able to do good on it. So starting off right away, if we have something like this where it's just two different, in this case binomials, being subtracted, well, you got to look for like terms. And you'll see there's absolutely no like terms, right? We have a 2x to the fifth. That's my highest exponent, so I'm going to write that first. My next highest exponent is this x to the fourth, but there's nothing to combine it with, and it's a minus 107 x to the fourth because of that minus sign there. So I'm saying minus 107 x to the fourth. Okay, and then we go, okay, no more exponents. There is a single x here, and it's a plus 620x. And lastly, we have this minus 9300 out back, but notice it's a minus a negative 9300. So when you have that minus and negative, it actually turns to a positive 9300. Okay, if you can't tell, as I'm making this video, I'm fighting a little bit of, hopefully it's just allergies, maybe it's a small cold. Either way, I apologize if you hear me clearing my voice a lot or clearing my throat a lot, but we will get through this. So going on to the next one, if you are dividing a polynomial like so by x minus 6, you're saying, okay, I need to throw something up in the box here, right? That's how we divide polynomials. We do this synthetic division. And I'm always throwing up in the box whatever is going to make this equal 0. Well, 6 minus 6 is 0, so I throw a positive 6 up in the box. And now I have 7x to the fourths. Notice I have 0x to the thirds. That's very important that we don't just go and say, okay, 2x squareds. Okay, we have 0x cubes, 0x to the thirds. So I need to say that. And now I go on to the fact that I have 2x squareds, negative 5 single x's, and then 24 out by itself. Okay, and then if we're going to do the division here, I'm going to bring down my 7, and now I'm always multiplying by my 6. So 7 times 6 is 42, and then I add straight down. 0 plus 42, well, that's just 42. Okay, now is probably when you got to get the calculator out and say, okay, 42 times 6 then. Okay, that is 252. Okay, 2 plus 252. Well, that's going to be 254. Okay, go to the calculator. 254 times 6 then. That is 1524. So I'm going here. Okay, negative 5 plus 1524. That's going to be 1519. Whew, we're getting to some big numbers here. That's okay, though. So 1519 times 6 now. That's 9114. Okay, I lastly add straight down once more. 24 plus 9114 is 9138. Okay, and it's saying, well, do the division, but which number is the remainder? It's always going to be this last one, and you throw it over that x minus 6. So that 9138 over x minus 6 is your remainder. All right, moving on to number 3. What is the factored form of this polynomial? Okay, notice it has 1, 2, 3, 4 terms. When it's 4 terms, that's how you know it's probably going to be factored by grouping. So I draw a line down the middle. Let's try to get this a little bit zoomed in for you. Okay, so I draw a line down the middle and I'm saying, okay, what can I divide out of both negative 3w to the 5th, negative 27w to the 4th? Okay, well, both negative 3 and negative 27 are divisible by negative 3, so I'm going to pull out a negative 3. And not only that, they both have at least w to the 4th, so I'm taking out negative 3w to the 4th. Now from there, I can say, okay, well, then when I take that negative 3w to the 4th out of negative 3w to the 5th, I'm left with just a w. The negative 3 is taken out, and then 4 of the w's is taken out. I'm left with 1. Okay, we're dividing by a negative 3, so it's going to become a plus, and negative 27 divided by negative 3 is a positive 9. Take out w to the 4th out of w to the 4th, well, then that's all we're left with is that plus 9. Okay, now I'm looking over at the next two terms separately now, saying what can I take out of both 5w and 45? Okay, well, both of those are divisible by 5. Okay, so I'm going to take out a 5. And when I do that, take a 5 out of 5w, we're left with w. Take a 5 out of 45, we're left with 9. Okay, so I now have my factor by grouping. These should match in order, if you did it right, these should match. And they do. So when I factor this, it's negative 3w to the 4th. I put my two leading numbers together, so negative 3w to the 4th plus 5. That's one parenthesis, and then my pair of w plus 9. Oops, I don't know what I was writing there. W plus 9 is my second parenthesis. Okay, going on to number 4 then. If I have something like this, okay, and they're just saying, well, this is f of x, this is g of x, what is f plus g of x? Well, then we're just going to add the two together. Okay, so these are almost lined up pretty nicely for us. So I'm just saying, okay, I have negative 9x to the 4th, and remember, you can only combine like terms, so I can only add my x to the 4th, so negative 9x to the 4th plus 13x to the 4th. Well, negative 9 plus 13 is 4, and that's x to the 4ths we're talking. Okay, going on to now, I'm going to see if I can focus this. I realize the picture's not the best. Good news is you obviously have this paper in front of you, so you can see it well on that, and you can hear me talking through this. And now we have a negative 5x plus a negative x, so that's negative 6x. And then I have a 10 plus 201. Well, that's just plus 211. Done. Okay, again, we're to the point where I should probably give you the reminder. Please make sure you're trying these on your own and then using the video to check your understanding, to see if you were on the right track, or use the video to get yourself unstuck if you get stuck by any of these. But please make sure you're not just watching and copying down, not even really thinking about it, because that's not going to prepare you for the test, obviously. So I just wanted to make sure I said that. But now, when we're asked about turning points, okay, we have to figure out what degree is this polynomial, okay? And to do that, you add the exponents. So this is an exponent of 1 plus an exponent of 2, so that's 3, plus 1 more, so that's 4 total, okay? Exponent of 1 plus 2 plus 1, 1 plus 2 plus 1, that's 4. Degree 4. Turning points, always 1 less than the degree, so it's 3 turning points, okay? And if you don't believe me, you could shove that into Desmos, and you would see that there as well. Okay, so 3 TP, 3 turning points. Okay, what polynomial equation has roots 0, 5, and negative 3, okay, and they want it in standard form? Well, first let's write the factored form, okay, and if we have a root of 0, well, then that means there's going to be an x all by itself, and then if we have a root of 5, well, then we have an x minus 5, because 5 is what makes that equal 0. And then I have a root of negative 3, so that means I have an x plus 3 because negative 3 makes that equal 0. And now I got to just multiply these out. So starting here, I have x times x, that's x squared. X times negative 5 is negative 5x. Okay, and now I have to multiply that by the x plus 3. So now I guess we kind of got this in a place where I can go ahead and make my box, and I can put x plus 3 on the side. And now I can just fill this in. X squared x squared times x is x to the third. 3 times x squared is bottom left here. That's 3x squared. Okay, top right, we got negative 5x times x. It's negative 5x squared. And then bottom right, 3 times negative 5x is negative 15x. And now I just need to combine my like terms, and out over here I will have my final product. I have 1x to the third. And then I have negative 2x squared. And then I have negative 15x. Okay, and if you don't get where I got this negative 2x squared, 3x squared minus 5x squared, when you combine those, or 3x squared plus a negative 5x squared, that's the negative 2x squared. So I combined those. These two are left alone, which is why they appear just as they are. And that's your standard form with those roots that were given. So you got to start with, okay, well, what's the factored form? That's what you can get from this. And then you multiply your factored form out to get the standard form. All right, moving on. We are determining the zeros of this polynomial, but they give us one of the factors, okay, which means I already know one of my zeros is, well, what makes x plus 4 equal 0? That's negative 4. So that's one of my zeros, but there's going to be more. And I got to do some polynomial division here, some synthetic division, in order to find the rest. So I'm throwing a negative 4 up in my box for synthetic division because negative 4 is what makes this equal 0, right? That's why it's one of the zeros, negative 4. And now I have 1x to the third. I have 5x squared. I have negative 2x's. And then I have negative 24 as my number that's alone. And now I just have to go ahead and do my synthetic division. So I bring down my 1, and I have 1 times negative 4, that's negative 4. 5 plus a negative 4, remember, we're always multiplying up here and then adding straight down. 5 plus a negative 4 is 1 again, so 1 times negative 4 again is negative 4. Negative 2 plus a negative 4 is negative 6. Negative 6 times negative 4, well, that's positive 24. So we're left with no remainder, which is good news. So now I'm saying, okay, well, it started with an x to the third. So now since we divided, we're starting with a 1x squared plus 1x minus just 6 out by itself. Okay, so that's what I'm left with. And now I need to factor this to find the last two zeros. Okay, so maybe you are someone that needs to make the little crisscross and say, okay, I need two numbers that multiply to negative 6, okay, multiply to negative 6, and add to 1. Okay, and really you have 3 and 2, or 6 and 1. 6 and 1 will never add to 1. 3 and 2 are 1 apart, so that will add to 1, and it's adding to a positive 1, so that's how you should know it's going to be a negative 2 and a positive 3. Okay, so my factors are x minus 2 and x plus 3. Well, what makes each of these 0? And maybe I'll write my factored form out here. And if I'm saying, well, what makes each of these 0? Well, positive 2 makes x minus 2 equals 0, and a negative 3 makes x plus 3 equals 0. So those are my zeros of the function. Okay, going on to the next one. This one should go pretty quick. Is there a vertical compression going on? There's a 6 out here. That will be a vertical stretch. It would be a compression if it was a fraction, but it's not. It's a 6, so that is false. That's a stretch. Translated to the right. Well, if it was translated to the right, I should see an x minus something. I see an x plus something, so that's going to move it to the left, 12. So it's not going to the right. And then it has a global maximum. Well, okay, think about it. This is an odd function, right? It has an odd degree, I should say. And if it has an odd degree, well, then that means it's going to go down all the way to negative infinity and up all the way to positive infinity. So it will not have a global maximum. Okay, it's going to do stuff in the middle, but in a sense, if I were to sketch it, it'll look something like that. Okay, and that's a very rough sketch, but that's the type of end behaviors it will have. So there is no global maximum because it will go all the way up to positive infinity. Okay, going on to the next one. If we have two functions, told that f of x is this, g of x is this, and it's asking, well, what is f times g of x? Well, that means we got to multiply the two together. So I'm going to put it on a box, and I'm saying negative 3x squared plus 2x. I'll put that on one side, and then on the top, and then on my side, I'm going to put 4x squared minus 5x plus 33 on the side. So now we have some boxes that we can fill in, and we can say, okay, 4x squared times negative 3x squared. Well, 4 times negative 3 is negative 12. X squared times x squared, that's x to the fourth. Down here, we got negative 5x times negative 3x squared. Okay, negative 5 times negative 3, that's a positive 15. X times x squared, x to the third. Okay, 33 times negative 3, negative 99. No x's here, but we have an x squared here, so just x squared. Keep going. We got a 4x squared times 2x. Well, 4 times 2 is 8. X squared times x is x to the third. Negative 5x times 2x is in this box. Negative 5 times 2 is negative 10. X times x, x squared. And lastly, 33 times 2 is 66. No x's here, but we do have an x there, so 1x. Okay, and now if they want the standard form, I just need to make sure that I combine my like terms. And if it's standard form, I'm writing highest exponent to lowest. So we're starting with the negative 12x to the fourth. And that one's done, so maybe cross it off. And now we're saying, okay, 15x to the third plus 8x to the third. Well, 15 plus 8 is 23. That's x to the thirds we're talking. Boom, done with those guys. Okay, negative 99x squared minus 10x squared more. That's minus 109x squared. Uh-oh, I'm running out of room here. Okay, and lastly, we just have the 66x, so just plus 66x. This is my completed standard form there. I started getting a little bit into the business over here, but that's all right. Okay, for part B, here's what I'm going to say. I'm not going to do this one for the sake of time, but it's as simple as using your graphing calculator. So take this standard form that you got from multiplying it out because it's asking about f times g of x. Well, that's what you just found. Okay, so to find the end behavior of this, take this, plug it into your graphing calculator or Desmos, and tell me what the end behavior is. Okay, so Desmos or graphing calculator for this one, you should see that the end behavior is, pause right now if you haven't found it, because I'm going to tell you it, but you need to find it. You need to know how to find this so that you can do it on the test. You should have found that the end behavior is A. Okay, let's move on to the very last page here. And if we are going to graph a function, okay, we're graphing a function, and we want to start by graphing, well, what are the zeros? Okay, and if we have an x out front alone, one of the zeros is at x equals 0. And then if we have an x minus 5, well, that makes another 0 be positive 5, because positive 5 makes x minus 5 equals 0. And then if we have an x plus 4 squared, well, negative 4 makes x plus 4 equals 0, so here we have another 0. Okay, now we need to see, okay, well, what degree is this here? We got exponent of 1 plus 1 is 2, plus 2 is 4, so it's a degree 4 polynomial, which we know that's either going to be end behavior like starts high, ends high, or starts low, ends low if there's a negative out front. Bingo, there is a negative out front. So it's going to start down here and it's going to end down here. So maybe that's something you want to even start your graph with your end behavior with the two arrows down there. And now you can kind of just go ahead and say, well, x plus 4 squared is a double root, and that's this negative 4. This negative 4 is a double root. So that means when I get to it, I have to hit it and bounce right back off. Okay, so that's where I start. And now I just need to make sure, well, no, there's no more double roots. So I just need to go through these last two. So I'm going to just bring it down here, and then I'll come back up to go through my root of 0, go up here a little bit, and then I got to come back down to go through my root of 5, and then I'm finishing out like that. And it's just a rough sketch like that. And that is perfect for a sketch. You hit your roots, you showed that you know that this is a double root, and that's what happens there. You got your end behavior correctly, like we talked about. So that is perfect. Going on to the very last one, number 11. Okay, number 11, it says we have the graph of a cubic polynomial, and we want to know the equation of the function in factored form. Okay, so based off of that, we want to know, well, what are the zeros? And we have a 0 at negative 3, and we have a 0 at positive 1, and that's a double. So maybe I'll make note of that. We got a double root at positive 1. Okay, so if negative 3 is a 0, well, then that means I have to have an x plus 3 as part of my factored form. Okay, and then I have a 1 out here, but that's a double root. So first off, I'm saying, okay, if I have a root of 1, well, then that means I have to have an x minus 1 because 1 makes 1 minus 1 equals 0. And if it's a double root, well, then I need an x minus 1 squared. Okay, now you just want to make sure your end behavior is good. It's an odd function, right? Like we have an odd degree. So odd degrees usually start low, end high. But since this starts high, ends low, you know that there was a vertical a vertical reflection or a vertical flip. So you should have a negative out front. And you get that by saying, well, this starts high, ends low. Most start low, end high, or all odd degree polynomials will start low, end high. Unless there's a negative out front, that's when it'll start high and end low. Okay, so that is something to be aware of there. Okay, now if we're stating the intervals of increasing and decreasing, well, actually, this is just asking about decreasing. So we're coming in and we're going downhill. Remember, we're reading from left to right, so that's why I come in up here because this is the furthest left point of my graph. And now I'm coming in and up until we hit this point here, which is probably like negative 1.8. It's hard to tell. It's just a little bit past negative 2 here, so like negative 1.8. So when x is less than, we can just say about negative 1.8, it's decreasing, right? Because then at this about negative 1.8, it starts to go uphill, so we're increasing right here up until we hit this point of x equals 1, and then we're going back downhill the rest of the way. So when x is greater than 1, we are going back downhill the rest of the way. Okay, and that's forever. Okay, lastly, is this an even function? If it was an even function, um, there should be some sort of symmetry about the y-axis, like reflectional symmetry. There is none of that, so that is false. Okay, is the range all real numbers? In other words, will this go up forever, down forever? This is saying it'll go up forever. This arrow is saying it'll go down forever. So yeah, it is all real numbers. It'll go all the way up to positive infinity, all the way down to negative infinity. Does this have a local maximum? Okay, a local maximum. Yes, it does, and it's right here. This spot right here is called a local maximum because that's the highest part of this portion of the graph where it hits like that maximum and then goes down. Okay, it does not have a global maximum because it goes up to positive infinity, but it has a local maximum here. This is also a local minimum here, no global minimum either. Okay, so that is your Unit 2 review. Remember that was Modules 3 through 5. Please Let me know if you have any questions, and good luck on the test.